Pause the video now, have a go at the question, and press play when you're ready for the solution. Okay, so in part A of the question, we're asked to complete the Venn diagram based on this information. So we have what's known as our universal set here. So these are all the numbers we'll be dealing with. So integers are whole numbers, so the whole numbers between 1 to 20, and that includes 1 and 20 itself. Then set A is the odd numbers, set B is the prime numbers, set C is the numbers less than 10. So before I even draw the Venn diagram, I write out all the numbers I'm going to need here, because it just visually, I think it's better. So we've got all the odd numbers that are between 1 and 20. So we have 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. Then the prime numbers between 1 and 20 are 2, 3, 5, 7, 11, 13, 17 and 19. And then numbers less than 10. I'm still going to write them, but it's obvious. Numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some people don't do this as part of their working out, but I'm a visual person, and unless I can see all the numbers all at once, I can't do the question.
10's not less than 10.
10's not less than... You're quite right. 10 is not less than 10.
But we'll leave this in because there's a deliberate mistake, because a lot of people think it is, don't they?
Yeah, exactly. I was thinking less than or equal to 10. Yeah, that was a trick. Right, okay. So now I'm going to draw my Venn diagram. Okay, so it's a free set Venn diagram. So it's going to look something like this. Those are fantastic circles. Right, okay, so A, B, and C. So I will start with the middle section. So here, this part is any numbers which are in the sets A, B, and C. So let's have a look. Are there any numbers which are in A, B, and C? Okay, so we've got 3 here, which goes in the middle. Matt can tell me if I miss any out. 5 goes in all 3 of them. May not have made this big enough. 7. It almost looks like 3 to the power of 5, I'm not going to lie. That's it, isn't it? I think that goes in the middle. Now I look at these intersections. So now I've got this part of the Venn diagram is any numbers which are in both set A and set B. Okay, so this is set A, this is set B. So we've got 11 and 13 and 17. Okay, so 11, 13 and 17. I'll just keep moving around. So this is the part which is in set B and set C. So set B and set C. So that's 2. Is that it? I think that's it. Okay, and then in set A and in set C. Okay, so A and C. So we've got 1 here. Then we have, I think that's, no, we've got 9 as well. 9 as well, okay. And now all the rest of the numbers are easy to fill in. So anything that's left in set A, we just put in here, and this is why I like to cross them off as I go. So we've got 15.
19 is in A and B. Isn't it?
You're quite right. See, this is going super well, this question. Right, so we've got 19 as well in A and B. Okay, this is why we cross the numbers off. Okay, so we've just got 15 in that one. Set B, we have nothing left, and then in set C we have 4, 6 and 8. Okay, the last thing we have to do now is, I haven't actually drawn my Venn diagram properly. What I should have done is drawn a box all the way around it, and this represents the universal set. Okay, so any numbers which aren't in set A, set B or set C will be outside of these circles here. So we just have to check whether there's any numbers that are left. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is in none of them, 11, 12 is in none of them, 13, 14 isn't in any of them, 15, 16 isn't in any of them, 17, and I've got 18 and 20 as well. And that's my completed Venn diagram, which I'm sure Matt will now say I've gotten wrong. Okay, so in part B of the question, we're asked to find the probability that a number is in the set A and B. So we can write that as so. So the probability that the number is in the set A and B. Some people call this A intersection B, some people call it A and B. It's good to know both of the terms. I'm going to use A intersection B, okay, because I think it's clearer when we're talking about the diagram. So A intersection B is literally where these two circles intersect. So you can see here that the circles A and B intersect in this portion here. So let's just count how many numbers we've got up here. So 1, 2, 3, 4, 5, 6, 7. So we have 7 numbers out of a total of 20. So the probability that a number is in A intersection B is 7 over 20. In part C, we're asked to find the probability that a number is in the set A or C. Okay, so I'll write that down. So the probability that a number is in A or C. Okay. Once again, there's two different terms for this symbol here. So you can either say A or C or A union C. In this case, I'm going to use the word or because I think it's a little bit clearer. Some people might disagree with me. Okay, so we've got the circles here, A and C. Okay, so when we're talking about A or C, what we're trying to say is it's either in the A circle or it's in the C circle. So if it's in the A circle, how many options do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or it could be in the C part, okay? 11, 12, 13, 14. So there's 14 options out of a total of 20. In probability, I don't really simplify my fractions, but you can do. So obviously that would simplify to 7 over 10. The majority of probability questions, you'd get the full marks if you didn't simplify. But if it explicitly says in the question, leave your answer in its simplest form, you would have to write 7 over 10. Okay, so for the final part of the question, part D, we're asked to find the probability that a number is in the set not B. And the way we denote that is, so we've got the probability that it's in the set not B. So you can see that this symbol here is not B, okay? So let's have a look at our Venn diagram. Lots of people will make the common mistake by just saying, oh look, this part is blank and this part's B. So everything is in not B. But when we're talking about the set B, we're talking about this whole circle here. So, oh, I've made that really gross now. Okay, so everything in this circle is in the set B. So we count everything outside of that circle. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 numbers outside of the set. So there's 12 out of 20. Once again, you can simplify. 6 over 10, or 3 over 5. But I would stick with 12 over 20.